So especially for anyone at home today, we are not starting just in your notes. We're going to start by talking about a problem. We need to help Rubber Ducky. Rubber Ducky would like to come visit Phoenix. He's thinking about coming here. He thinks it might be a good school for him. So Rubber Ducky wants to travel from his pond that's right near my house. So Rubber Ducky's pond to Phoenix. We are going to assume straight line of travel. So ignore the fact that Smoky Row actually runs slightly diagonal. Ignore the fact that Billingsley is not perfectly straight. We're going to assume straight travel, so those dotted purple lines are our travel lines. Now, Rubber Ducky is only going to take the road or sidewalk because, you know, he's a good law-abiding ducky. And these are real distances. Thank you to Google Maps. These are actual distances on here. So I want you guys, either on your own or partnered up with someone close to you, figure out the distance that Rubber Ducky is going to need to travel to go from his pond to Phoenix. My note or my hint would be to figure out all of the horizontal distance together instead of breaking it up. Do it all together and then figure out your vertical and then add it together. So it'll be about a minute, maybe a minute and a half. Yep. Figure out how far Rubber Ducky has to travel. Rubber Ducky, you're the one. You make bath time lots of fun. I'm going to go ahead and pass out your notes just so you guys have them. Just get that taken care of. No, he can't fly. He's going to waddle on the road or sidewalk. He's a law-abiding duck. He walks on the sidewalk. He doesn't want to go to duck jail. You know Duck, Duck, Goose? Duck jail is just an endless game of Duck, Duck, Goose with no gooses. Can you imagine just duck forever? All right, help me out. We've hit our minute and a half. Who figured out a way to look at your total horizontal distance? Is your hand still up or no? Yeah? All right, Justin.
All right, so after each of the lines, there's like a little mark saying how far the distance is, I think.
Okay.
And so the first line is 0.45. I don't know what
Is that an X coordinate or a Y coordinate?
Y.
Yeah, that's a Y coordinate, right? Because that's how high up it is from your X-axis. So if you look at your axes here, we've got the X-axis and the Y-axis. And the problem is that your origin or your starting 0, 0 is in the middle of everything that's happening. So if I had dropped it down to here or taken it up to here, obviously your life would have been easier. But how do we deal with the total horizontal distance? How do you normally deal with the distance between things or the difference between them? What sort of math do we do in order to do that? Please have your name tags on if you have them. Please, Izzy. Yeah, so say it louder. We can subtract. So normally the distance or difference between things uses subtraction. So to figure out my distance, somebody earlier said like it's going from A to B because we often talk about points as like here's location A and here's location B. So to figure out distance, let's say I'm going from A to B, I just say, okay, where's B? Subtract where I'm starting. That's how far I go. So I'm looking at total horizontal distance. Phoenix ends at an X value of 8/10. Rubber Ducky starts at an X value of -7/10. So if I set up -7/10 minus my 8/10, then I'm going to get a -1 5/10. So he's going to travel a -1 5/10 horizontal distance. Okay. I'll keep moving on then. So our vertical distance, what subtraction would I do there? For vertical distance, what are my two like reference values? Abby?
45
Yeah, 45 hundredths
and
and
-25.
negative 25 hundredths. So we can set up that 45 hundredths minus my negative 25 hundredths. Sorry, I forgot my zero there, but that's a 25 hundredths. Now wait, crap, minus a negative. How do I minus a negative? Take away a negative value? How do I take away a negative value? Seeing who remembers what we did last week? Xavier?
So is it basically like
Yeah, minus a negative is plus a positive. So these join up with each other to make addition. So that gives me really 45 hundredths plus 25 hundredths. And that gives me, well, 25 and 45. Forget the fact that they're hundredths for a minute. What's 25 plus 45? Yeah, 70. So then make them hundredths again. Do I need this last zero?
no?
No. So I could either say 70 hundredths or 7 tenths. So then to find out my total distance that Rubber Ducky travels, what do? I have a horizontal distance and a vertical distance. Justin?
Add them up.
Add them up, right? So in total, let's use black. So I'm gonna have my vertical plus my horizontal, and I get, well, which is bigger, my negative or my positive? Guys, I see some perplexed looks. I'm just waiting for those questions. So in total, Rubber Ducky traveled a negative 8 tenths. Of what? So wait, I thought horizontally he traveled a negative 1.5? No, we know where he's going to. He lands here at Phoenix. This is the actual Google map. Until you zoom in, it doesn't actually show Phoenix, so I had to put it on there. But so let's say the distance from here to Abbey is 12 feet. If I were to approximate, it's probably 12 feet. So, watch carefully. I might pull a trick. How far did I just travel?
12 feet.
Okay, now, this is where it gets dangerous. How far did I just travel? Well, okay, I love that you summed the both. But yeah, so 12 feet again, right? But I went a different direction. So wouldn't that be negative 12? Why? What? Not that they cancel each other out. I mean, the movement did. The movement got me back to the same place. Yeah, but so can I travel a negative distance? No. Distance can never be negative. So why'd you guys let me do this?
Yeah, why?
And what? Like, this is completely wrong. Distances can't cancel each other out. So CJ, when I said how far did I travel, said 24 feet because I went 12 feet and then I went another 12 feet. But even though I landed in the same place, you can't say, well, you traveled 0 feet. Well, that's a lie. I walked over there and then I walked back. Distance is always positive. So this is malarkey. That can't actually happen. The rule I'm trying to get you to see here is on your notes. Distance, we really set up as the absolute value of that subtraction problem. So when we put it in absolute value, what does absolute value do? Anybody, what's absolute value do? Makes everything positive. So when I talk about my total distance traveled, I'm going to take a positive 1.5 or 1.5 and add it with my positive 7/10. And how far does Rubber Ducky have to travel to get to Phoenix? Andrew? 2 2/10 of a mile. And that is actually how far it is when I ride my bike. It's 2.2 miles. So, that's the real distances. Yeah. Yes. So, our learning target here for today is that I can determine the distance between 2 points by solving the absolute value that's critical. Because it's so critical, let's just do this. Look how important it is. The absolute value of their difference, and understand that these distances have to be represented by a positive value regardless of what direction they're telling you to go. Direction does not matter. So, do we really need to finish these? Do you guys remember that minus a negative is plus a positive? Remember those addition rules? Which one's more powerful? Keep the sign that's more powerful. Take the difference. Can we move on past this?
Yes.
If we want to come back to it, we totally can. But for now, let's move on to your 4-6, which never ended up opening. Maybe a 4-6 could wake up. This would be good. I know it's an early morning for all of us. There we go. So, you ever find yourself staring up at the sky and with your cell phones and apps and things? You probably don't do this very much anymore. But you should know a little bit about clouds thanks to your elementary school teachers. Are all clouds the same?
No.
No. All clouds are not created equal. Anyone hear the giant storm that happened this weekend? Can we not break my chair, please?
Yes.
Yeah, there's a huge thunderstorm. What kind of clouds bring thunderstorms?
Storm cloud. Is it
Cumulonimbus. I love that word. Cumulonimbus clouds, these right here, bring thunderstorms because they're super tall. They have a lot of activity going on inside them, a lot of energy. So, some other types of clouds that we have are stratus clouds, and there's different types of stratus. So we have altostratus and nimbostratus. We're going to talk about what's the difference between the base or the bottom of that cloud, because depending on where the cloud is determines what kind it is. So if we try to figure out how far apart these clouds are from each other, would we want to do 1.3 minus 4.1, or would we want to do 4.1 minus 1.3? Whitney, can we help you with something? Would we want to do 1.3 minus 4.1 or 4.1 minus 1.3? Well, when we do subtraction, what's easier? Big minus small or small minus big? Big minus small, right? So to find the distance between these, we can say that our distance is going to be that 4.1 minus the 1.3. Then we can set this up vertically. You guys, if I'm writing, you should be writing. Sorry, yeah, my decimal got annexed by one of the other numbers, it looks like. Be careful with your subtractions. Some of us still forget that we have to borrow. I cannot take 3 from 1, so I borrow. 11 minus 3. 3 minus 1. So we see that the distance between the base of these clouds is 2.8. Now what would be this label? Kilometers, because we see kilometers there and we see kilometers right over here. Kilometers. So now, I want you guys to try that with the got it, but be careful, we have mixed numbers there. careful with the mixed numbers. You may work with a partner or check answers with a neighbor, whatever you want to do. How do we find the distance between these clouds? Now, one of the things that will get people into trouble is when they have options. Now, we have a lot of options. Why did I highlight what I did? Oh, do you have it out and I just can't see it? Casey. Sorry, Casey.
You highlighted the denominators because they're different, and in order to subtract them or add them, you have to make them the same.
Yeah, so here's our first choice. I can start by matching up my denominators, or how else could I start? Yeah, I can make them improper. So, Casey, what'd you do first? Improper or match your denominators? Match your denominators. So, what did you do to make this happen? To match the denominators?
I multiplied the numerator and the denominator of 1 and 3/4.
Yeah, so we're going to double these, right? Now, do I double the 1? No. So, the whole number does not get affected at all. So this becomes 4 1/8 minus 1 6/8. It's like taking a pizza and cutting it into more slices. You didn't change how much pizza you had. You just changed how many portions there were. Any questions on what we just did? So then I will what I call the triangle method to do improper. 4 times 8, then add it to the 1. So 4 times 8, 8, 16, double it again, I get 32. So I get 33 eighths minus, again, my triangle method, 8 plus 6 is 14 eighths. So now 33 minus 14, 19 eighths. And then we can turn this back into a mixed if we want. Ella? 2 and 3/8, because the 2 gets rid of 16 of the eighths. We have 3 left over. Justin?
Can we still carry with fractions?
What do you mean can't we still carry? What do you mean?
You can carry the numerator.
We did the subtraction. That's what I did, and I got the same answer.
I don't know what you mean by carry. You talking about doing it in the mixed number form or what?
Yeah, mixed number.
So when we would look at taking 6/8 away from 1/8, I would then have to, if you're talking about borrowing 8/8, is that the process you're talking about?
Yeah.
So I think Justin's talking about doing 3 and 9/8 minus 1 and 6/8. You can do that if you borrow one of the whole values. That's an option. Improper fractions are better to work with, and especially where we're headed with multiplication and division, we would use impropers instead of using the mix. So that's why we just default to improper. This works. That's totally fine. So if you want to, that's okay. Just make sure that you're comfortable with the improper method. Does that work?
Yes.
Yeah. Lily? Did you get 19/8 with me? So, did you get to our impropers right here? So, did you do your denominators first or impropers first? Denominators first. So did you get to 4 1/8 and 1 6/8? Are you there with us? Was that a yes or no? So when you tried to do your denominators, what did you do? How did you? But you can't. So you're taking the 6/8 away from 1/8. You turned your subtraction around because it's not 6/8 minus 1/8. It's the 1/8 minus the 6/8, and that's what the borrowing has to happen, where things get more complicated. And that's why we go to improper. So this is wrong. So I don't know this part. Yeah. How did you get 14/8 and how did you get 9/8? You're not writing out your work because that 14/8 is wrong. So guys, I'm going to solve this again. If you have not written out the entire process, feel free to get Post-its or something else to write the process again, because some of us are struggling with fractions, and this is definitely worth taking the time to make sure that we are comfortable. So guys, if I was doing this process, I see 4 1/8, 1 3/4. This is what I'm trying to find the difference between. In my opinion, it is easiest to go to improper first and then make my denominators match. In my opinion, it's easiest to go improper first. So, to go improper, and this is, I believe, where some of us are goofing up. Take your whole times your denominator and add it to your numerator. What's 4 times 8? So that's 32. Plus 1, we get 33/8 minus 1 times 4. Add it to the 3, we get 7/4. Yeah, you can't. You have to start with your denominators the same. So I still can't do the subtraction because my denominators are still not the same. So to make my denominators the same, I say I need to double the 4. I can't just do it on bottom, so I have to do it on both places. You with me still? This now becomes 33/8 minus 14/8. Denominators start the same, have to stay the same. All I do is 33 minus 14, which is how I get 19, and then I can convert back into a mixed number if I want.
I did proper.
So if you still have issues on that, please come see me during AO or extensions. We got to keep moving on. Yeah. Yeah, there's some on that back shelf thing right there. Or that.
Oh, okay, okay.
Sorry, my toss was a little short. So now we're talking about this whale, and there are some people that say that we know more about the space close to us than the ocean on our planet, because the ocean goes really, really deep, and up until recently, we haven't had like vessels that could go that deep under that much pressure. So luckily now we do. We have vessels that can go pretty much anywhere in the ocean. CJ?
When you were talking about the storm this weekend, it reminded me, like, there's been a tree there since I moved to the house like 7 years ago, and me and my brother were running outside, and the wind just ripped the roots out the ground.
Yeah, really, really strong stuff. And we'll talk more about that as the year goes. So we're going to talk about how much space does this whale operate, like what is the range of his space that he swims under. And he goes from the twilight zone to the midnight zone. Midnight zone, called that because of how deep it is and how dark it actually gets down there. So we're talking 10,000 feet below the surface. That's almost 2 miles deep. You were to go straight down 2 miles. So, again, to find distance between them, it's either A minus B or B minus A. Right here, you might want to highlight this. Distance between A and B. It's always absolute value because it has to be positive. It's either A minus B or B minus A. Now, when we're working with both negative numbers, our distance it doesn't really matter which one you start with. So I'm just going to say negative 10,200 minus the negative 2,500 minus a negative. Minus a negative. Yearning for new hands. I guess I'm making our cards tonight. Abby?
Okay, so minus the negative is you use the negative to convert the minus into a
Yeah, because it's really the opposite of negative, which is addition or positive. So I get absolute value of 10,200 plus, sorry, this is still negative. Don't forget that, 2,500. So now I have addition. Addition's good. We like addition. First question we ask ourselves, when I'm adding, first thing I ask, what will be the sign of my answer? So to determine that, we have another question to ask. You know what the question is, Izzy? So you're right, but you're one question ahead of me. We have to first see, are they the same sign or different sign? So they are different signs. Remember, we don't do absolute value till the end. They are different signs. So then we say, which one's more powerful? So the negative is more powerful. So I'm going to bring down my absolute value, and I'm going to bring down a negative because I know that the negative is more powerful. Now, since they're different signs, now I want to, since they're different signs, I need to find the difference. So I just subtract them. If you have any space left, 10,200 minus 2,500. I'm going to need to borrow from the 10. This becomes a 9. And that becomes a 12. So 0, 0, 7. 9 minus 2 gives me another 7. I believe 7,700. But wait, that's negative. The absolute value then does what to it? Absolute value makes everything positive. And then make sure we label it. All my labels have been feet. So our label is feet. So that is how we determine our range between those two values. So remember, range is always the distance between your highest and your lowest. My lowest was negative 10,200. My highest was negative 2,500. Because we're talking about below sea level. Hopefully the whale is not swimming above sea level. That is always bad. So now when we talk about these situations, distance between P and Q, Q and R and S, hopefully we're going to see something here that makes a whole lot of sense. I need a volunteer. All right, Lily, now the question is, do you want to be on camera or off camera? Okay, so, you want to come on up here? Lily, are you feeling positive or negative today? Positive? All right, how positive are you feeling? Okay, so let's say you're positive 10. Let's make our life easy. So Lily's positive 10. I'm feeling kind of negative, so let's say I'm negative 5. And let's say my camera, like tripod, whatever you want to call that, is 0. So I'm going to need to travel from my negative 5 to Lily's positive 10. Now, can I get from my location to Lily's location without passing 0? No, there's no way, because on the number line, negative 4, negative 3, negative 2, negative 1, I have to go past 0 to get to Lily. But as soon as I pass 0, now I'm positive 1, positive 2, positive 3, positive 4. But the thing about going past 0 is, Lily, if you wanted to get to 0, how far would that be? And when I want to get to 0, how far is that? So since we're on opposite sides of the 0, we can really look at what's her absolute value and what's my absolute value. And we know that that whole distance has to be covered. So what's the distance between us? 15, right? Because her positive 10 distance And my distance of 5, even though it's in the negative direction, that doesn't matter, makes a total distance of 15. So thank you very much, Lily. That's exactly like this situation right here. I want you to put a little star next to the distance between Q and R. When you have one that's positive and one that's negative, Q, R, think about the fact that they have to pass 0. How far for Q to get to 0? If it's at -2, how far for it to get to 0? 2. How far for R to get to 0? So how far for them to get to each other? 5. Easy as that. So we could set up negative. Actually, I would always start with the positive first because then minus the negative becomes addition. But either way, we could just add up the values, the absolute values between the two of them. Now, Q to P, they're both negative. That's a little bit different. So Q to P, our top one here, P is a -5, Q is a -2. Now, wait, since they're both negatives, -5, -2, what's the distance between them? Is it -3?
No.
I can't tell if that was a yes or a no. It was like, yo.
No. Because distance can't be negative.
Distance can never be negative. So guys, here's the trick. If they're both negative, treat like they're positive. So if they're both negative, treat like they're positive. And all you really need to think of is what's the distance between 5 and 2. Or I can show the work, -2 minus a -5, -2 plus 5. Huh?
Wouldn't you have to use 5 first?
No, it doesn't matter. Because it can be A minus B or B minus A. Because it's absolute value, that makes the order of the subtraction not matter.
Oh.
Normally it would. And then the same thing happens if they're both positive. Well, if they're both positive, treat them like they're both positive, because they are. And the distance between 5 and 3, even if so, here's that sort of situation. Abby, if I do 3 minus 5, I get -2, but it's the absolute value, so it still becomes 2.
What with R and S, there's positive. R.
I know they're both positive, so I got a negative answer, but then it becomes... So the other way I could do it is 5 minus 3, which would give me the absolute value of 2, which still equals the same thing. Order doesn't matter because the absolute value. Any questions? All right, let's move on to the back. Oh, so if you didn't have space on the front, I always forget about this. Because I ran out of space, my copy bumped this to the back. If you didn't have space to show that work, there's some space right there. But now we want to show the work just for finding these distances. I have positive, negative, 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 and positive, positive. So, set up an absolute value expression. I don't care what your order is, but in my opinion, again, that's not a right, wrong. In my opinion, if you have a positive and a negative, put your positive first, because then minus the negative, it makes your life a whole lot easier. The minus and negative becomes addition. Which becomes the absolute value of 6, which just becomes 6. Again, you could just add their absolute values since they have different signs. Their absolute values summed together would give you 6. Now again, if they're both negative, we could treat them like they're both positive. What's my distance going to be here? If they're both negative, treat them like they're positive. Distance between 5 and 1? 4, right? But if I do the work, I can say -5 minus -1, which becomes -5 plus 1, which becomes -4, which absolute value is just 4. Any questions with these so far? And then our last one, both positive, should be real easy. Any questions? Practice. Years of practice. And I write quicker actually on a vertical surface than I can on a horizontal surface. Which of these correctly express the distance between -2 and 4? There could be multiple answers. So take a second. Which of these would correctly represent the distance between -2 and +4?
I would just recommend trying to solve
Yeah, so if I think about let's just solve it, remember, if they're different signs, I can really just sum their absolute values. Because how far does -2 need to travel to get to 0? How far? 2, thank you. How far has 4 got to travel to get to 0? 4, so I know that really the distance between them is 6. It's really just we're finding which of these equals 6. Well, what's 4 minus 2? 2, and the absolute value of that would be 2. That doesn't work. -2 plus 4 is again 2, actually, so that doesn't work. -2 minus 4 becomes -6, but then absolute value becomes 6, so that works. 4 plus 2 becomes absolute value of 6, which is just 6, and that works. Any questions on distance between two values? Now we have 4 minutes left. I'd like to go ahead and pass out the notes for tomorrow. So somebody might need to remind me that I went ahead and gave you guys the notes. You can go ahead and work through the 4-7 homework if you want. It's posted in the 4-7 folder. The 4-7 folder does not look like there's a whole lot going on because it's just the problem-solving folder. So that will often be where people ask questions and I need to post some extra things or whatever. That stuff can go in there. But a lot of times problem-solving is just wrapping up.
Wait, is this
Sorry,
kind
Andrew.
of like negative, like, not negative, is this just like 4-6?
In a way. So let's start talking about this first problem because if we get done with your lesson early tomorrow, what's up? You should have called me. Call me. If that happens, call me. I'll get you through it. Because I can't help you with it now. We're in the middle of class. Yeah. I love how musical you are, but can we knock off the whistling in my class? It's just constant. Like, and I was trying to let it go thinking you'd get bored eventually, but I guess not. So if you can't stop whistling in my class, we'll have to put you in like a bubble like the Pope travels around in so that nobody can hear you, and that will be really annoying. If you ever watch the Pope Mobile, he's got like this bubble thing that he sits in. Nobody can see him, hear him, get to him, talk to him, shoot him, and like it's a impenetrable bubble. So we have some friends, and I'm pretty sure that these friends are playing a joke on their friend. So they're at Amy's house, and they're going to go to Michelle's tomorrow. So they're explaining to people how to get from Amy's house to Michelle's house. And they said, okay, well, first, Juan lives 2.5 blocks away from Amy. Okay. And then they said, okay, so then Michelle lives 3 3/4 blocks away from Juan. So I want you guys, you can partner up or whatever, figure out where might Juan live and where might Michelle live. It'll tell you there are multiple options for both. So figure out where might Juan live, where might Michelle live, and we are going to pick this up right here tomorrow. So take about 30 more seconds. You should be able to get all 4 of these down. The more you get down today, the quicker we can get done tomorrow, and then we can have work time at the end of class. Then you may clip this all away in your math section. Please make sure you have your name on your math notes too. And then we can head on out to our block 2A. Thank you guys very much. Please call or text me if you have any issues on the homework.